Hello everyone, welcome back to the channel me.u. In this period, we will move on to the last lesson of this chapter, equations of lines parallel to x-axis and y-axis. First of all, we have to recall the word linear equation. Are the following equations linear? We have two equations here. Is it a linear equation? First of all, we know that equation means it will have an equal sign. Yes, both of them have equal sign. Linear means the power of the variable or the power of the variables will be 1. Here both of them have only one variable. Here the power of x is 1. So this is a linear equation. And in the second example, the variable is y. The power of y is also 1. So both of them are linear equations. Now, the question is, how can we represent these linear equations geometrically? Linear equations will always have, as the name refers, will have a line. If you have an equation with two variables, it will represent a line. If you have only one letter, it will represent a point on a number line. So let us see how can we do it. How to graph this? So if you consider x equal to 3 as an equation with one variable, we can represent it on a number line. Here is a number line. X equal to 3, doesn't matter x or y or any other variable. If you have only one variable, just represent it by a point on a number line. X equal to 3. So this is the representation or geometric representation of the equation x is equal to 3. What about the next one? Don't get confused. If you have y, you should represent it on a vertical line. No, whatever is the variable, if you have only one variable, just we can represent it on a number line. Y is equal to -4. So you can mark it here, y is equal to -4. This is how you can represent an equation with one variable. Now, can the same equation be represented on a Cartesian plane, and how does it look like? To represent an equation in the Cartesian plane, we need two variables. So first of all, we are rewriting the equation in the form of two variables. So x plus, we don't have y, so we can insert 0y. We have learned it before. And how to write it in the standard form? Just taking it back to the other side. So -3 is equal to 0. This is the standard form of writing an equation in the form of ax plus by plus c is equal to 0. Now, how can you represent this? So whatever value of y you give, the value of x remains to be 3. So let's draw a table to find the values of x and y. And you know that to represent an equation on a Cartesian plane, we need only 2 points. You can have more, but at least you need 2 points. So if the value of y is 0, x plus 0 minus 3 is equal to 0, or x equal to, you will get the answer, x is equal to 3, because 3 can be on the other side. So x is 3. What if you take the value of y is 2? X plus 0 times 2, again it is 0. Minus 3 equal to 0, so again it will be 3. So the points are 3, 0 is a coordinate on the Cartesian plane, and 3, 2 is also another coordinate on the Cartesian plane. So let us represent this. 3, 0. 3, 0. This is the point 3, 0. Another point is 3, 2. 3, 2. If you take, let's say 5 for the value of 5, for the value of y, it will be 3, 5. So you can notice that all the points will be in the same line. And this represents the equation x is equal to 3. And you know that this is parallel to y-axis. Let us see the second equation. How does it look like? Y is equal to -4. So we can rewrite this equation with x by inserting a 0x plus 1y or y minus 4 plus 4 is equal to 0. Now let's draw a table to know the coordinates. For any value of x, y, the value of y will be negative 4. If x is 0, y will be y plus 4 equal to 0 or negative 4. If x is equal to 1, 0, 0 plus y plus 4 is equal to 0, or we will again get y is equal to negative 4. For any value, if you take, it will be the same situation. So we have 0, negative 4 is a coordinate, 1, negative 4 is another coordinate, 3, negative 4 is another coordinate. Let's represent 0, negative 4. 0, negative 4 is here, 1, negative 4 is here, 3, negative 4 is here. So we can see that it is a line passing through negative 4 of the y-axis. And what can you notice about this line? It is parallel to x-axis. This is a line or a graph representing the equation y is equal to negative 4. So this will satisfy the name of the lesson. Lines parallel to x-axis and y-axis. You can see that if x is equal to 3 is the equation, or if the equation has only x, it will be parallel to the other letter, which is parallel to y-axis. Again, if you have the variable x in the equation, it will be parallel to the opposite axis, which is y-axis. Again, look at this one. You have the variable y in the equation, so it will be parallel to the opposite of y, which is x-axis. Did you get the idea? So let us see an example. Without graphing, you can just guess. X is equal to negative 9. How does this line look like? The variable is x, so it will be a line parallel to opposite of x, so it is y-axis. What about the next one? Y is equal to 4. Yes, so it will also be a line parallel to the opposite of y, which is x-axis. Did you get the idea? Great. Why are they parallel? Because we don't have both the variables. We have only one of them. Let's see in detail. Is the equation 3y plus 2 equal to 2y plus 5 an equation in one variable or two variables? Let's rearrange them. 3y plus 2 is equal to 2y plus 5. Let's collect all the y's together. This plus 2y, let's take it back. So it will be 3y minus 2y, and plus 2, let's take it front to collect the numbers. 5 minus 2. 3y minus 2y is 1y, which is y. 5 minus 2 is 3. Y equal to 3 is the equation. So is it any linear equation? Yes, this is a linear equation, but does it have one variable or two variable? In one variable. And you know, this can be represented geometrically on a number line because you have only one variable. So y is equal to 3. So 0, 1, 2, 3. So this will be the point y is equal to 3. Okay, how can it be represented geometrically on a Cartesian plane? For that, we need to rewrite it in two variables. So let us rewrite the equation in two variables. So y is equal to 3. So this can be rewritten as 0x plus 1y minus 3 is equal to 0. And how can it be represented on a Cartesian plane? Let's draw with a table. If the value of x is 0, y will be 3. If the value of x is 2, again y will be 3. So let's represent it. 0, 3. 0, 3 is a point. 2, 3 is a point. If you take 5, also it will be a point. So you can see that it is a line parallel to x-axis. Why is it a line parallel to x-axis? Because our equation is y is equal to 3. If you have only one variable, we studied that it will be a line parallel to the opposite. Opposite of y is x-axis. Is that clear? Let's move on to your exercise. Give the geometric representation of y is equal to 3 as an equation in one variable. So geometric representation means we have to graph them. If you have one variable, we studied that it can be represented on a number line as a point or in a Cartesian plane. So as one variable, we need only a number line. So y is equal to 3. Just mark a point at 3 and that's your answer. Now, how do we represent it using two variables? We don't have x, so we can insert 0x plus y minus 3 is equal to 0. Now, to represent it on a Cartesian plane, we can draw a table, x and y. If x is 0, y will be 3. If x is 1, again y will be 3. If x is 5, y will be 3 again. So the points are 0, 3, 1, 3, 5, 3, and everything will end with by variable as 3. Now, can you guess how does the line look like? Y is equal to 3. It has only one variable, so it will be parallel to one of the axes. To the opposite of y. Yes, excellent. So it will be parallel to x-axis, passing through y equal to 3. You know y equal to 3 is a positive number, so it will be above 0. So passing through 3, you will get a line parallel to x-axis. Let us see how to mark it using coordinates. 0, 3, here it is. 1, 3, again here it is. 5, 3, again here it is. So see, it is a line parallel to x-axis passing through the point 3 on the y-axis. Let us see another example, which is question 2. Give the geometric representation of 2x plus 9 is equal to 0. So again, we have only one variable, but we can rewrite. 2x is equal to negative 9 because plus 9 changes to minus 9. Now we have to remove 2 to keep the variable alone. So you know that x is equal to negative 4.5 is the value. So how do we represent it on a number line? Negative 4.5. Here it is. So this is the equation of, or this is the geometric representation of the equation x is equal to negative 4.5. Now, how can we rewrite this in the form of two variables? We don't have a y value, so we can insert 0y plus 9 equal to 0. Now, when you draw the table, now you don't need a table. You are an expert now, right? If the value of y is 0, the answer of x will be negative 4.5. Even if the value of y is 1, it will be the same. Let us mark it on a Cartesian plane. Negative 4.5, 0. Negative 4.5, 0 here. Negative 4.5, 1. So it will be a line passing through negative 4.5. This is a line parallel to y-axis. Why is it so? Because this is an equation with x. So we studied that if you have a variable with x only without y, which means it will be parallel to an axis. Which axis is it? Opposite of what you have. You have x, so it will be parallel to y-axis. So we are done with the whole chapter. Hope all the concepts are clear. And the most important thing from this whole chapter is how to identify an equation. Is it a linear equation or not? And understand that if you have the word linear, which means it will always represent a line in a Cartesian plane. And if you have only one variable, it can also be represented on a line by marking a point or a dot on the number line. So here the homework for you is to draw the graph of linear equation 2x equal to negative 8 in one variable. In one variable means you will have a number line. You can represent a point on a number line. So you have to divide by 2. So you will get x equal to negative 4. So it is your time now. Do it yourself. And you can submit your homework in the comment box. Thank you so much for watching and hope all the points are clear to you. Any comments, you can get back to me through the comment box. Good luck and see you in the next chapter.